And you can either start now or take a few minute break.
I'm going to give them a 5-minute break.
I think they need that. That was pretty terrible on my
Yeah,
part.
I can hear the smoke coming out of their ears. But if you have any questions for me, I'm going to be sitting here for the next 5 minutes.
And I will let the video keep running.
Are y'all using the Anaconda?
Yeah,
Dr. Cleveland was using the Jupyter notebook that you can use through Anaconda.
Oh, okay.
I'm going to try to run the lab from CoCalc, not to make it too strange for you. But it's pretty much the same.
Yeah, I'm trying to figure out how to like separate my documents for like my labs for Jupyter on Anaconda to like organize it, but I can't seem to do it.
I can show you how I would do it, so let me go ahead and
Please
share my screen.
I would literally just find the directory it's storing it in and then build subdirectories within that from the file system like he's doing.
Assuming that you have it installed, if you search for Jupyter Notebook, it will bring it up for you, and then when you run it, it will open a browser environment for you similar to this. Now, at least to me, this is identical to the files section of the CoCalc. So you can just go ahead and upload all your documents here. So as you see, for example, I have my Lab 12, my Lecture 12, Lesson 12, all the notebooks, all the CSV files, all the image files that I want. I'm just going to bring them here. Something that you need to notice that is kind of unsimilar to CoCalc, you cannot just drag and put everything in here. You need to click on upload, go and select the files that you want, and then let them be uploaded in order for you to have access to them.
Okay.
And then once you have them here, for example, let's say I have my Lab 12, I just click on it, it will open another browser for me, and I will be able to see it. And this is, again, very, very similar to CoCalc. You have your cells, you can run them, you can cut them, or edit them in any way you want.
Okay, thank you.
Yep. Let me see, what do we have in the chat box? Will CoCalc work too? Yes, Brandon. It will work, except it gets down on server like the other times.
Okay.
Yes.
Do you know how to delete folders in Jupyter Notebook without deleting its content?
How do you want to delete a folder without deleting its content? In any environment.
Okay. Yeah, so for some reason, when I opened my Jupyter Notebook in Anaconda, so there were just like, maybe like 100 files.
Yes.
Folders, pardon. So, and I wanted to delete them, right? And then,
so you have like a bunch of folders here, very similar to what I have, right?
Can I share my screen actually?
Yes.
Yeah. Here, can I see? So like I have.
Yes.
Yeah, so I have all these folders, right? And I don't know where they came from.
They look like system files to me.
Those are
yeah.
Those are database files. Open one of them. Open one of the funny ones, like E2.
That will be on you, Ajibek. Whatever's in there.
Yeah, that's...
No, so look, so these files are uploaded to Jupyter Notebook, right? So if I delete them here, they won't be deleted in my system, right?
No, this is if you look at the top, it's showing localhost 8889. So if you delete it, you're deleting it on your machine, and that's okay. And then if you want to delete them all, the way to do it, I could talk you through it, but let me try to show you. I'll show you how if you want to do a massive delete. What kind of computer are you using? Is that a Windows or a Macintosh?
It's a Windows.
Okay, I will set mine up to try to show you how to do that.
Okay.
As soon as I can shrink you, let me get my Windows machine coming. This is outside the scope of what we intended to do, but it seems like this is as good a day as any to get that done. Okay, so let me share my screen briefly. Okay, let me get a Windows instance running on mine. Oh, rats, I forgot where I put it. So it should be in there. Windows 1064. This will take a few seconds. I'll just show you how to do it, and then.
Okay, thanks.
So if it was a Macintosh, I would show you how to type a system command which removes everything, which is not the smartest thing to do, but if you want to make them go away, you can. Hopefully those system files don't do anything else that's important.
Yeah, fingers crossed.
Yeah, hopefully.
Yeah, you have your original Windows operating system that you could reinstall if you had to? That'd be a no. That would be a no.
Yeah, probably.
And let's see, while that's going on, let's do something in the background. Delete directory. RMDIR, that's the command. So there's our friend Google again. We're going to try to exercise this command from your Jupyter Notebook. So my password, hopefully I typed it right that time. Okay, that's a win. So let me go ahead and first create a directory. New folder on the desktop. Seriously, could you go any slower? So here we have this folder called Go Away, and I want to get, see, it's got some files in it. I'll throw a checkpoint in there. Okay, so there's this folder. When I run Anaconda, Navigator, and I'm going to want to delete the Go Away folder, and it contains things. Maybe in my lifetime it will run.
Yeah, I just noticed that it takes files from your existing documents or like videos, downloads, music, and pictures / videos, and it has it there.
Yes,
so like you even have to upload it.
You want to be sure you want to destroy the files.
Let me see if I delete it in this existing. Will it delete?
If you delete it and we do not see you anymore, good luck, brother.
System 32 deleted.
Okay,
I don't need that.
That's why the first question, do you have your original Windows operating system to reinstall?
Oh, yes, I do.
I have it on a server somewhere because I just downloaded an ISO image. I never actually got media.
Yeah, my license is through my email, so that's pretty handy.
As long as you have a license key, you can probably just go to the Microsoft website and download an ISO image and reinstall, which is a pain in the neck.
It's so annoying.
Okay, so here we are in a Jupyter. Here we are in a Jupyter environment. We go to desktop, and I want to make go away, go away. So what I'm going to do is I'm going to create a new. This is a stupid way to do it, but it'll work. Create a new notebook in the directory that contains the directory that I want to delete stuff in. I guess I should just open the terminal window and do it. That was stupid. Then I want to exercise a system command. Let's see if I'm in the right directory. So there's this directory called go away that I want to make go away. I'm going here and it says, do you want to delete a directory from Windows? This post explains how to use rmdir. So I'm going to type rmdir in the directory name, but I want to force it. So looks like the -s option's what I want to do, and then the force delete is -q cap -s. So that's what we're going to do.
Interesting.
Let's just try to do it. First, we'll just do it the way we know won't work. So system command rmdir, directory name, go away, and it should give me a message that says the directory is not empty. I'm not going to delete it. Classic. So now we will force it with the -s -q. Okay. Again, we have to use our friend Google. Here goes nothing. And let's see if the directory is there. It's gone. So that's how to delete entire directories in Windows. For Macintosh people, I would have done the same thing, except I would have done rm-rf directory name. Same thing. So the nice thing I like about Anaconda and Jupyter is that you actually have access to the operating system. So before you go ahead and do that, be sure you don't need those files for anything. And
so it really does delete it?
Yeah, it's gone forever.
Okay.
Yeah, so you say I have all of my desktop files there, it turns out. So
if they're system file, I mean, they have the look of a system file because they have that weird naming convention. They might be supposed to be there. You may want to just live with it. The way you'll find out.
You can actually create a new folder, name it whatever you want, and put everything you want in that folder if looking at them bothers you.
Yeah, if you were to look on my computer, you'll see a lot of folders called scraps and junk. I just put everything in either of those, and that gets them out of the way without destroying them. So let me stop sharing. I think
by the looks of it, it really does delete it.
Yeah, Brayden, we just got bored and we started deleting our system files.
Oh no.
Are you good, Michael?
Yeah, I'm good. It's just, I feel so, like, I don't want to be touching this stuff now.
So I just showed you dangerous stuff. So don't delete unless you're absolutely sure.
Man, I try to separate my C drive from my hard drive and my other stuff. Now it's close.
May the force be with you.
And also with you.
So, let us begin our lab. We are getting close to 10. Here we go. I hope that you have all downloaded all the notebooks and the CSV files. As I said earlier, what you need for the lab is the actual notebook and 2 CSV files. One of them is named Lubbock _October _TNP, and the other one is called Air Traffic. So, let me bring up my CoCalc, my chat box. Thank you, Andrew, for covering that question. Lab 12. Okay. So, if you have your Lab 12 notebooks open in front of you, you will see our old familiar information cell on top, which you are going to fill with your own information, hopefully. And then we have our descriptive statistics with Python. And I want you to go ahead and double click on that cell and notice a new method that we are using to embed images in our notebooks directly from the web. So in this method, you do not really need to have that image in your working directory. You just need the exact address of that image on any websites that you may find it there. And you will just paste it here. And if you run it, and it should be in Markdown cell, of course. If you run it, it will just bring up that image for you. So, before we begin the actual work, I want to ask, what did you understand from the first 2 hours of today's lesson? What were we doing? What is descriptive statistics? You can either unmute yourselves or type your comments in the chat box.
What I got from it is that we're just essentially pulling out information from an array or a data table, and then we're just getting things like the mean and the geometric mean, and I forgot what the other 2 other means were, but just essentially information that you can get from the numbers in a data table.
Not bad.
Okay. Thank you. Any other comments? Okay, so yes, what I read in the chat box and what Max just explained are pretty close. Basically, what we are trying to achieve by descriptive statistics is information and ideas about data that we have. As you start using more and more of these codes and techniques that you're learning in this course in your career, you will realize that we are dealing with big data in many cases, huge data sets, thousands of rows, hundreds of thousands of rows in cases. And simply looking at them and saying, that's what they look, that's what they have, that's the characteristics of this data set. It's going to be almost impossible or very, very, very difficult to do simply by looking at a huge data set. So we need numbers, we need plots, we need statistics to be able to describe a data set, to talk about a good guess for the central tendency, a good guess for the spread of the data, for the shape of the data. And that's basically what we are trying to achieve in this lesson and this lab. Here we are importing our necessary libraries. The first two and even the last one are already familiar to you. The third one and the fourth one are the ones that we are mostly introducing in this session, and they have a very useful and common tools in terms of statistical functions. So let's run that cell and import those functions. Our example 1 is a multi-step problem. You have seen similar problems like this before. In the first step, it is asking us to read the air traffic.csv file as a data frame and check its first few rows. So, since we know that this is a CSV file and you have probably already downloaded it, we will use the read underline CSV function from the pandas package. And using this syntax, we will read that CSV file and assign it to an object that I'm calling AT for air traffic. You can call it whatever you want, but you need to stay consistent with it. And then because we want to have a look at the first few rows, we run the head function, which is one of the descriptive functions we have covered in our pandas session. Pardon?
I was yelling at my computer.
Oh, okay. So when you run that, you will see that this data set has 6 columns. Just as a piece of information, this has information about some flights in year 2020. We are looking at the distance, the original country, the destination country, the aircraft group, the class, and the data source, whether it was international or domestic. Then on step 2, we were asked to use descriptive functions of the pandas library to learn more about the data frame. So I'm using the info function, and by using that, I'm not sure if I had run this, okay. And by using that, I'm learning that in addition to the 6 columns that we have already seen, this has 118,278 rows. So that is a huge data set. And for you to simply go in and looking at each column and getting some practical information is impossible. There are some other information given by this info function that we are not really interested in. It's giving us the size of the file, and we are not interested in those at this point. So, for step 1 and 2, do you have any questions? Are we good? Yes would be a good answer if you're good. Yes. Thank you, Ben.
How do we do the second part?
I'm using the info function from the pandas library. So similar to how I typed the head function with the name of my data frame dot head open parentheses close parentheses, I run the info function. Okay, thank you all, Liana, Brandon, Max, and Hannah. So let us move to step 3. Compute the arithmetic, harmonic, and geometric mean of distance. So, when we want to work on a specific part of a data frame, the first step that we need to do is to separate it out. So, I'm creating a new object. I'm naming that distance. You can name that whatever you want. And from the AT data frame, I'm calling the column with this heading. When you are doing this, you have to make sure that what you have here is identical to the name of the column. And by identical, I mean identical including every single space in there. So it should be exactly the same. And when I do that, then I'm going to use the mean function from the statistics library to compute the arithmetic mean of my distance column. And I'm using this printf statement to say the arithmetic mean distance of the 2020 flights is, I'm rounding whatever value that arithmetic mean is by 2, and the units is miles for those US American unit lovers. So we're going with miles. And then for the harmonic mean, from the same package of statistics, we are using the harmonic underline mean function. And I've modified this statement, so it's saying the harmonic mean distance of blah, 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 yes. And then for the geometric mean, we are using the geometric underline mean function from the statistics package. So all the three means that you are interested in and you are asked to compute can be done with a one-line code using the statistics package. And when we run that, it will report whatever we wanted. So the arithmetic mean is almost 1,100 miles. The harmonic mean is 220 miles, and the geometric mean is almost 620 miles. Do you have any questions about calculating these means?
We're basically just changing all of the distance to whatever our column shows. So, for example, mine would be date instead of distance.
You can, if you have a date column in your data frame, you can put that here, and then you can separate out the date column. However, computing an average of date, I don't think that's a very useful thing to do. But yeah, if you need to do that, that's the way to go. Here in the first line, you're basically saying that, okay, I'm separating out the part of the data frame that I'm interested in, and then you're doing the rest of your calculations based on that.
Okay.
Okay, so those no's are for questions, and we can proceed. Find the median of distance. So again, since we are interested in the distance column, we are separating that out, and then we are using the median function from the statistics package to compute the median. Question. I want one of you to either unmute or all of you to type in your answers. What is the difference between arithmetic mean and the median?
The median is like the middle value, while the arithmetic mean is like summing all of them and dividing by the number of data points you have.
Exactly. Thank you very much.
Actually, close. The median is the value that separates them into half below, half above. So oftentimes medians are not actual values in the series. I find that extremely confusing, but but you're basically correct.
Yes, basically the way that we calculate or find the median is that we rank all the numbers that we have. For example, in this case, we are ranking all the values in the distance column, either in an increasing order or a decreasing order. That doesn't really matter. Then if the number of elements in our list is an odd number, the value that falls right in the middle, that will be our median. But if that is an even number, then we have two middle values. And we will compute the arithmetic mean of those two values, and we will report that as our median.
Declare that the median.
So, do we have any questions about the median?
No, sir.
Cool. So something else that we have also touched on during the lecture is that using median over the arithmetic mean or the average is recommended when you have extreme values or outliers in your data set. And the reason for that is since median only cares about the rank of the data and the position of those values, it doesn't really care whether a few values are extremely high because it's going to put them at one of the ends of the spectrum. But mean, since it's basically adding up all the values and dividing them by the total, is sensitive to the actual value of each element. So if you have one or two or a few extremely high or extremely low values, that's going to directly and heavily impact your average. That's something to keep in mind. For step 5, you're asked to find the most frequent origin country and the most frequent international or non-US destination. So let's see what we're doing. First, we are defining an object called origin, and we are calling the column name origin underline country underline name from the AT data frame. We are doing a similar thing for destination, but I am converting that to a NumPy array. And the reason that I'm doing that is that there is a tricky part about the second part of the question. It wants us to look at the non-US destinations. So I actually need to go in and create another object called destination underline non-US, which goes into the destination NumPy array and removes all the values that has United States in them. So my destination underline non-US is a list of the destination countries without United States. And then I can use the multimode function from the statistics package and see the mode, which is basically the most frequent value, or the value that has been repeated the most. And when we run that, you see that the most common destination is United States, most common country of origin is United States, and the most common non-US destination is Canada. Do you have any questions about what is happening here, especially this part? I'm hearing yes, of course. So the question is asking us to find the most frequent origin country, part 1, and find the most frequent international non-US destination, part 2. So I'm interested in both of these columns, the origin country name and the destination country name. What I'm doing is that first, similar to what I've done before, I am defining an object, I'm calling that origin, and that will be all the values in the origin underline country underline name column of my AT data frame. Nothing new here. For the destination country, I'm doing the same thing here, but I am converting that into a NumPy array. Because of what I'm asked to do, I need to convert that to a NumPy array in order to be able to delete all the United States entries from that list. And that deleting is happening in the third line. I'm basically saying that go to my destination array, and wherever the destination is equal to United States, delete it. So at the end, my destination underline non-US will have all the values in my original column of the data frame, except the ones that had United States in them. And once I have that, I will go ahead and run the multimode function from the statistics library or package on those two objects and print out the result. I hope that was helpful, Max. Cool. Do we have any other questions on this part? Okay, let's go on. Step 6 is asking us to find the range of distance. What is the definition of range?
Max minus mid.
Thank you. So you only care about the maximum value in your list and the minimum value in your list. And the subtraction will give you the range. So what I have here is that I'm using the PTP function in NumPy, which stands for peak to peak. And that gives me the maximum distance minus the minimum distance. What do you think is a big limit in using the range function?
Outliers are included. So.
Exactly. So since it only cares about two values in your entire data set, so we have already discussed in this data set, for each column, we have 118,278 rows. So out of all those numbers, range only cares about two, the maximum and the minimum. So you have no information from what's happening in the middle. That's one limitation to it. And then it is extremely sensitive to the outliers. So if you have one very, very, very high number or one very, very, very low number, or even both, your range may give you an unrealistic interpretation of your data set. So especially if you want to solely rely on a statistic, range is probably not a very smart choice. So, on the next part, we are asked to find the inter-quartile range of distance. What is IQR?
Quartile 3 minus quartile 1.
Yes, and what is a quartile?
It's like for like quartile 1, it's kind of like the median between the highest value of the 25th of like the first quarter, and then the highest value of like second, third.
You're getting kind of close. So the idea of a quartile is that, let's assume that I have all my 118,000 values set right in front of me. And I want to use 3 little walls to divide all these numbers into 4 groups of equal share. So once I build these walls, I will have an equal amount of numbers on this side, on this side, on this side, on this side. So 4 parts with the same number of elements. Those walls are called quartiles. And the reason for that is, I think it is coming from Latin, I'm not sure, but I know that, for example, in Italy, there is this very famous pizza that is called the Quattro Stagioni, which means the 4 seasons, and it has 4 parts to it. And similarly in English, we say a quarter, which is 1/4 of something. And the IQR, sorry, Brandon, I'm doing that to myself as well, so we are in the same boat. The IQR basically cares about the Q3, or the 75th percentile, and the first quartile, or the 25th percentile. And if you want to compare IQR and range, it is believed that IQR is a more practical tool because of the same reason that median is preferred over arithmetic mean, since they are not as sensitive to outliers and extreme values. So here I am again separating out my distance column, and I'm using the quantiles function from the statistics package. I'm running that on my distance object. I'm setting n equal to 4 because I want my data to be separated into 4 parts or 4 sections of equal share. And when we print QS, it will give us the 3 quantiles, 25, 50, and 75. And then if I'm interested in the interquartile range, or IQR, I will simply use the IQR function from the skippy.stats function, and I'm running that on my distance object, and the result will be given to me. So, do we have any questions about quantiles and quartiles and IQR? Are we all good? Exactly, yes, Max. That is an object that I'm naming, so you can name it whatever you want. Any other questions? Okay. So then we are asked to use descriptive functions of the pandas library to get a 5-number summary of distance. Plot the box plot without outliers. So,
Right.
You have a question?
Yeah, so quartile is a third, not a fourth.
It is a 4th, but you have 3 of them, right?
Okay.
So let us think about a very simpler version of it. So if I have a pizza, since we are on this object, if I have a pizza and I do 1 cut straight in the middle, how many parts will I have? 2. So 1 cut, 2 parts.
Yeah.
If I do 2 cuts, how many parts will I have?
4.
No. It really depends on how you're cutting it. But if I have a line and I do 2 cuts, I will have 3 parts.
Yeah.
So similarly, if I do 3 cuts, I will have 4 parts. So they are breaking your entire data set into 4 parts of equal length.
Yeah.
So we have 3 of them. Does that make sense now?
Yeah, I vaguely understand.
Cool. Another question that I'm getting from Kalian. Actually, let me scroll back down here. Kalian, if you set n equal to 4, the outcomes of that will be quartiles. But the cool thing about this function is that it gives you the power to divide your data into as many number of equal shares as you want. So if you want to have 3 parts of equal length, you can set n equal 3. If you want 10 parts of equal length, you can set n equal to 10. And it will give you those dividers and their values. Does that make sense? Cool. And Brandon, did you get the answer that you were looking for?
Yeah, it just really depends on how we cut the pizza.
Yes. Yes.
Yeah. Okay.
As long as we're eating all of it, yeah.
Actually,
it's good.
You should use a breadstick as your example.
That would be way smarter,
because
yes.
You cut the breadstick once, you have 2 pieces of breadstick. And one of those 2 pieces you can cut again. So the second cut gives you a total of 3 pieces. You could use the bigger piece that's left over, cut it. That's 3 cuts, 4 pieces. And that's what the That's what the quantile. There's no such thing as a third quartile max, because quartile is the Latin word for four. But the walls between the two are the first, the second, and third quantiles that associate with 25th percentile, 50, and 75th percentile.
Yes, they are the dividers that we are using to.
It's all word choice because statisticians need job security, so they pick weird old words to confuse the hell out of us. So a quartile is breaking your data into four equally sized parts, size being the count of the number of things.
Exactly.
A quantile is the relative percentage of the total data set that a particular value represents if they're ranked from small to big or big to small. And if you can get those two, that's all you need to know about those words. Because those in a couple bucks will still get you a beverage, it's funny using those references because we can't go out and play right now.
Do we have any questions about this part? And if you have questions, please ask, because it is important that you feel comfortable with these terms and words and calculations.
Pretty easy. Pretty good.
Okay.
It makes sense.
Cool. I'm glad. So, for the next part, you're asked to use descriptive functions of the pandas library to get a 5-number summary of distance. And then you're asked to plot a box plot without outliers. So what is a 5-number summary?
It gives you max, first quartile, median, second, third quartile.
So it is your 3 quartiles, the minimum value and the maximum value. That will be the 5-number summary. And it is very useful. I personally have used it a lot because it gives you a very good idea about the spread of your data. And it is truly a good summary for many cases. So we can use, and we have already talked about it during our pandas lecture and lab. So we can use the describe function. Brayden, it is the min, it is the max, and the 3 quartiles. Q1, Q2, Q3. So if we use the describe function from the pandas library, it will give us these values. These 5 are basically the 5-number summary. It also gives us 3 other values, the count, or basically how many entries or rows you had in that column, the arithmetic mean, and the standard deviation. Usually, these 3 are not included, and that is why it is called a 5-number summary. But since Pandas is a very cool package, it is kind enough to give us all this information by one simple function. So that will be the results of running a 5-number summary or describe function of on our object. So what we are seeing here is that the minimum distance was 1 mile. The maximum was 9,779 miles. And something important that I want you to notice is that when we computed the range, the value came out to be 9778, which is basically 9779 minus 1. Max minus min. But if you notice, there is a huge gap between the 75% percentile or the third quartile and the max. That is why we always suggest using the 5-number summary and not solely relying on max minus mean. Because according to this, max could be one or a part of a few outliers and not a common value. However, if you had your third quantile to be very, very close to your max, you could say, okay, then probably I have a lot of values close to 9,000. So judging by these numbers, you can get a lot of information about the spread of your data and the values that you're looking at. Plotting a box plot. We are using the box plot function. We are feeding our object and then some characteristics for how we want it to be plotted. So in show flyers, I currently have false, but if you change this to true and you plot it, you will see something like this. So you have your box plot in the bottom of the plot, and then you have a thick black line, which is basically a lot of empty black circles that are compacted together. Those are box plot is not like a bell curve. You will definitely learn more about that in our next lecture. But let me just say that a box plot is a representation, is a graphical representation of a 5-number summary, and you will know more about that in a minute. So these circles are outliers. So actually in this data set we have quite a lot of outliers, especially on the higher end of our values. If I set this to false and I want a box plot without including my outliers, I will have something like this. So a box plot has 5 major points or pieces of information. The value here in the top, which is currently around, I would say 2,700, this is the maximum. And then the value on the bottom is the minimum. And then the point that the box starts at is our 25 percentile or the first quartile. The value that the box ends at is the third quartile. And this purple line in the middle is the median, or Q2, or the point where half of your data falls below and half of your data falls above. So that's what the box plot tells you. It is a graphical representation of your 5-number summary. The bell curve is the shape of a normal distribution data model. I'm not going to go into detail on that because that is something that we will cover in our next lab. But I would say that these are two rather different concepts. You can have a box plot for any numeric data set that you have, but the bell curve or the normal data model is a function that you can use to see how your data is distributed over a certain length. So, do we have any questions about the 5-number summary and the box plot? No? All good? Okay. So, for the next part, we are asked to find the variance and the standard deviation of distance, and then also find the skewness and kurtosis of distance. So, we can use the statistics library, the variance function, and the stdev function to compute the variance and the standard deviation. Something that you need to keep in mind is that standard deviation has the same unit as your data. So for example, in this case, if we are working with miles, the unit of a standard deviation is also miles. But variance is a different story. That does not have the same unit. It probably has the same unit to the power of 2, but that is not meaningful in many cases. So that's why in a lot of statistical and engineering practices, we prefer to stick with a standard deviation when possible. And we can use the skippy.stats library and use the sku function and the kurtosis function to compute those two values as well in a similar syntax and get those values as well. So, do you have any questions about the last two steps? Variance, standard deviation, skewness, and kurtosis. No questions? Do we have any questions about example 1, the entire example 1?
For the box plot, if you don't want outliers for your data, do you set the, what was it, show flyers to true?
If you set it to false, it will not show the outliers. If you set it to true, it will show the outliers.
Okay, so when you're saying you don't want the box plot with outliers, you mean you wanted to set it to false because you don't want it to show the like dots of the outliers.
Exactly.
Right?
Yes. And you don't have to keep redefining distance. Yes, Andrew, you don't have to do that. I just do that for the illustrative purposes. So, Kaylin, let me actually go back to the lecture. This is the formula for calculating variance. And the important thing that you need to keep in mind is that the standard deviation is the second root of variance. And basically by doing that, we bring it back to being the same scale and the same unit of our data. What it tells us is it is a measure of data spread. So unlike mean or median that are telling us information about the center of our data, this is telling us some information about the spread of our data. So when I have a bunch of numbers, let's say I have 100 numbers, looking at median, looking at mode, looking at average, it will tell me that, okay, if I want to pick one number to be the representative of this entire range of numbers, 100 numbers, where would it make more sense for me to put that pin on? That's why they are measures of central tendency, because they're giving us information about the center of those data. But then we have measures, we have statistics that are describing the spread of data, similar to variance, similar to standard deviation. Actually, what the standard deviation communicates with us is that if you know the mean or the arithmetic mean of your data set, there is a very high chance that the majority of your data will be around that mean. And when we are defining around, we need a radius, or we need a step size to both sides. That step size is the standard deviation. So if someone tells you that I have a data set with the arithmetic mean of 50 and the standard deviation of 10, that means that if you look at 50 plus 10 and 50 minus 10, basically, if you look at 40 to 60, there is a high chance of capturing a lot of the values of the original data set in that distance. So a standard deviation is telling you the spread of your data around your mean. And Dr. Cleveland, please correct me if I have misexplained this. And Kalian, please let us know if that was a helpful explanation for you.
I'm waiting on Kaylin's reply.
It was, thank you. Okay, great.
Okay. Yeah,
when
you take your probability and statistics class, you'll see variance again, and it's going to be taught to you as the second moment of the distribution. And in the civil classes and mechanical, you'll learn about moments of things, and it's basically how far away from the center if you apply a force to make the thing tip. And so variance is classically taught as a second moment of a distribution. It is. I mean, it's just a definition. And that's where the squaring term comes in. And they're trying to convey the same information, but they do it on a much different scale.
Thank you, Dr. Cleveland.
Yeah, I think I just confused it.
Pardon?
Sorry, I think I probably confused everyone. Stop where I started.
I don't know. Kalian, do you have any more questions about this? Okay, cool. So now that we have covered example 1, exercise 1 is very, very similar to that. You are given another CSV file named Lubbock_October_TNP. So this data is coming from Prism, which is a database for climate data. You can actually go online and have a look at it. This data set has mean temperature and precipitations recorded in the month of October in Lubbock from 1895 to 2019. Actually, let me bring up the data set. Yes, so if you open that CSV file in Excel, what you will see is a data set like this, which has one column for date, one column for precipitation, and one column for temperature. And it's going to have 125 rows for the 125 years of data that you're dealing with. So, in every step, you are asked to do certain tasks, very similar to what we did in the example. Please make sure that you add the right comments to your code. We don't want explanation cells for them, but when you are writing your code, add comments and say what you're trying to do and what you are achieving in every step. That's one part of it. And then for exercise 2, we are asking you to share your ideas on the importance and applications of descriptive statistics, especially in engineering. So this can be 1 or 2 paragraphs of you going over why you think descriptive statistics are important and what are some of the applications that comes to your mind in dealing with engineering problems that may involve descriptive statistics. Please let me know if you have any questions about exercise 1 and exercise 2 and what you need to do about them.
Can you explain to us what exercise 2 is supposed to be again? I was trying to charge my computer.
Exercise 2 is basically a markdown cell, 1 paragraph or 2 paragraphs of you explaining the answer to the question. Why do you think descriptive statistics is important. In what kind of engineering problems and in what parts of dealing with those problems descriptive statistics may be utilized and useful. Any other questions about exercise 1 and exercise 2?
I have a comment on exercise 2. If you reach out to Google to get ideas on how to answer that, be sure you cite your sources. And all you got to do is grab the URL and drop it in your markdown cell. But you're still supposed to do your own writing, so you'll have to interpret those for us because we're stupid on exercise 2. So treat it as a research exercise because that's its intent. And see why you think that would be important, especially in the areas of engineering that you're particularly interested in. So Farhang and I could tell you what we think is important, but it's going to be clearly a water perspective because that's the field that we're working in. But you probably all have different ideas, and so we'd like to hear them and share them with everybody.
Water is the field that we are working in, and the coolest of engineers do the same. So
yes, especially in 107-degree days, water is the cool stuff to be in.
See? Liana, yes, it does have to be engineering. So you're not interested in engineering?
Actually, so you're going to like next lecture a lot.
Yeah, probably.
Yeah.
So I didn't know that you're not interested in engineering. I would have spent more time on making it look cooler and cooler for you.
It's like, yeah, I think I'm like the only non-engineer here.
So Max, the answer to your question is go Google it.
Yeah. So if there are no more questions about Lab 12 and the exercises, I am going to stop sharing my screen so that Dr. Cleveland can wrap up this session. Thank you, everyone. Be safe.
Thank you, Farhang. That was a great lab. I was working on something else in listening, and I want to wish you all a great day. This lab is supposed to be relatively easy, so don't feel that you've done something wrong if it just worked for you. The second one is to get you exploring your own thinking and maybe doing a little of research, but it's not meant as a novel. A couple of sentences, maybe some citations, and that's good to go. Our next lesson is going to be a little more intricate, but I think it'll be a good one. And actually, I just realized I looked at the time. I have to terminate this call. I will get the stuff uploaded sometime tonight, and I will link it back to the Blackboard. And sometime this week, I'll be posting the exam grades. So take care, everybody. Goodbye.
Bye.